Well, welcome to this next video in this Arduino C++ series. And of course, this is Arduino C++ for the ESP32. Now, in the last video I did, which I think was number 157, I looked at using ESP-NOW in broadcast mode. And that's great in that you can have as many boards communicating as you want. But as I showed in that video, there are problems in that anybody can pick up the data in your transmission. Now, going over to the workbench, which is pretty boring, to be honest, this is the ESP that I'm going to be using, if you like, as my master, although in this series there isn't really a master and a slave. This technically then is my slave board, so these two boards are communicating. This one's going to send a message every second. This one's sending a response every 2 seconds. And then we had this third board down here, and this was the wrecker. This was a board that's just sending out transmissions on the same channel as these other boards. And in the last series, in the last video, I showed how to write a simple bit of code that would filter out any bogus transmissions. So quickly going over to the resource page at the Digital Town website. Again, the link is below the video. Now, once you're on the ESP32 page, just scroll down and we have the last video, which was on broadcast mode, and this week's video and the code expressive documentation, which is this bit of information here. And then there was also a link to how to use a FIFO buffer. Now, I'm not going to repeat all of the last video. I'm literally going to start where we finished in that video. So going over to the Arduino IDE, this is sketch 3. This is the broadcast sketch. This is the receiving sketch. And I'm just going to stop the movement here so we can see what's going on. And if you remember, what I did was these first 4 bytes of the transmission became an set of ID numbers that were being used to make sure that the transmission is for our board. So if we now look on the other board, we can see exactly the same header is being sent in the packet of data. Then I had put in the what do we call this thing? The MAC address. And again, you can see the MAC address on the other side. I then got a board ID. So this is being sent from this board here, which has an ID of 2. This board is receiving these messages from this board, which I've given an ID of 1. I was then sending over a time in milliseconds, what's that? That was an ASCII character and a counter. So these different values were coming over, and this is the time in milliseconds. It's going at 1 second intervals. Obviously, I've got my ASCII character that's coming out. We can see here J, K, L, M going through the alphabet. And then we've got a counter that is incrementing by 1. So at this point, all the data is being sent between the two boards and everything is working absolutely great. However, there is one sort of weird security issue here in that although we've put a prefix to the board, we're actually broadcasting this information out. So anybody could pick up this data, and if they wanted to be a bit mean and nasty to us, they could start sending data to our boards with exactly the same header as we've put in, and that would sort of mess up our system. So if you like, this is the key to the door, and what we really need to do is encrypt this data so that anybody receiving the data can't see quite what is going on. Now, if we go over to the expressive documentation, it talks about security, and ESP-NOW has a built-in security system, a very nice encryption system. There is one problem though, and that is the way that we are working in broadcast mode. So encryption is only available on paired devices, and you can only have a maximum of 17 paired devices. Now, for the projects that I'm working on, 17 is not enough. I need more than that, and that is why broadcast mode is so useful. The other thing about broadcast mode is that I can add a new board at any time, and I don't have to then reload all the code into all of my boards to add the new paired device, which would be a real pain. So what we now need to do is work out how we can add some encryption while not having to, if you like, put in the addresses of all the other boards and go peer-to-peer. So let's get started with sketch 1, and we are creating our packet of data, and then all I'm doing is serial printing out the values of that data. I'm just going to let it scroll down for a few seconds, and then let's just take a look at this and see how it's working. Right, we have our 4-digit prefix for our messages. That tells us that this is for our system. Let's stop that scrolling now. Then we're going to go through. We have the decimal values for our MAC address. Normally you would see these in hexadecimal. We've got our board number, and then we send an unsigned long. So that's made of 4 bytes. First byte hasn't even got a value yet. Second byte, we haven't got that far yet. Third byte is coming along. You can see the value changes by about 4 each time. When we come to the 4th byte, you know, if you think about milliseconds, they're whizzing by at pretty high speed. We can see that the 4th value changes quite dramatically on each transmission. The next value is an ASCII character, and I'm just increasing the value by 1, so that's not changing much. And the last 2 bytes were a counter, just an integer, and again, that's only changing by 1. It hasn't even got to the point where it's changed the high byte yet. So if I was looking for an encryption key out of all of these things, I'd really probably start by looking for the most changeable line of data, and that is byte 14 in this example. Now, I'll be honest, the best way to have done this would be to use a random value and to put it in an odd position. Now, one of the problems with programmers, we tend to be quite methodical. So if we're sending a transmission, we start with the header, and that tends to have information about the packet of data that we're sending. If you go up and look at the version of the ESP-NOW transmission, you can actually say that they actually do the same. They start off with a header, and this header has all sorts of information in it, and it's only after, if you like, you've got all the information in the header that you then start with the actual data that is transmitted across. Now, it's this sort of predictability that hackers often use as a vulnerability, because if you like, they know to look at the beginning of any transmission because that's probably where the key data is going to be held. So what we're now going to do is we're going to mix it up a little bit. Let's just uncomment this. So what I'm now going to do is I'm going to use byte 14, which is that byte that's changing quite rapidly. And I'm going to whiz through all the other bytes in the transmission, and I'm going to add the value of byte 14 to it. So if you like, I'm going to use byte 14 as my encryption key, but it's a key that's going to change on every single transmission. So let's just upload that and just see what it does to our data. So now as the data is coming through, we can see the original data. We get line after line with the same values to start the packet. Now we start with the encryption, and suddenly we see that all the values are looking far more random. Now, if you look very, very carefully, and especially if you know the previous values, there is a pattern that you can start to see. But if you look at it as it is, already the data is pretty jumbled up. Now, if we were writing this system from scratch, then what I would do is add a line like this. I'll just uncomment that. And I would probably insert this somewhere here or here in that header. So I'd have another line of data, which would be a random value. And because it's a byte, I'm going to set a random value between a minimum value of 1 and a maximum value of 255. For those who've not used the random function gives you a random value between the first value and 1 less than the second value. So as I only need a byte, that's all I need. And if I put that value in here, it's, if you like, in a bit of an unexpected place. So it's quite useful sometimes to think a little bit outside of the normal way of doing things. And if you hid your encryption key here, it would probably cause, it would be a little bit more difficult to figure out quite what's going on. However, for now, we'll stick to byte 14. And what we're now going to look at is how we're going to now encrypt that and then decrypt it. Now, moving over to sketch 2, we're going to send the same packet of data. I'm going to serial print out the original line, and we're going to prefix that with original. We're then going to encrypt the packet. So all we're doing is adding that value of byte 14, and we're adding it to everything else except for byte 14. I'm then going to serial print out the encrypted version, just as we did before. And now we're going to do the decrypt version. So the decrypt is exactly the reverse. If you add the value of the 14th byte, then for the decrypt, we need to subtract the value of the 14th byte, and then I'm going to serial print that out. Now, once that's been done, this is what we get. Let's just stop the movement. And we can see that the original 34243, that's our layout code, or if our system code. We've got the MAC address. Obviously, the MAC address is usually hexadecimal, and I'm printing it out in decimal. We've got our baud address of 1, and then we go through our other bits of data. We're actually encrypting off this byte here, I think, is it? Yeah, that's the one. So once we've encrypted it, these are the values that we then get. And then, of course, the important thing is the decryption. Do we get exactly the same values as we had on this line? And as you can see, the answer to that is yes. So although the data is now being encrypted and then decrypted successfully, and we might look and think, wow, these values look absolutely nothing like the values, the original values, there is still a very, very slight pattern if you are looking carefully, and you can get little ideas when numbers are the same. And that's because realistically, we are just adding the value of one column to all of the other columns. So let's have a look at how we can just mix it up a little bit more without needing any more encryption. So for the sketch 3, we're going to have the original just as before. However, when we come down to the encryption, now look at how, if you like, we've spiced it up a little bit. So just as before, we're not going to encrypt the byte 14 because we're using that as our key. But now what I'm doing is, if the value of byte 14 is less than 100, then we're going to add the value. If it's 100 or greater, we're going to subtract the value. Now that means that although, if you like, the key originally there was easier ways to sort of see patterns, this is really now going to destroy the simplest of patterns and make it far, far harder, if you like, to break our little simple encryption key. Now, of course, immediately afterwards, if we've encrypted it that way, we then have to decrypt it. So I'm going to serial print out the encrypted version. Then once again, I've got to use that same format, but of course, where I had an addition, I've got to have a subtraction, and where there was a subtraction, I've now got to have an addition, and we're then going to print those values out. Now, I've already got the system running, so let's jump down and just stop the scroll again. So the good news is that we have a line of original data here, and we're getting the decrypted version is coming out exactly the same. But when I start to look at these different lines of code, the encrypted lines, for me now, the pattern that I was looking at that was a little bit obvious has now started to become even weirder. It's much, much harder to see in the pattern of data. Now, of course, this is very, very simple encryption. If you wanted to make it even more complicated, what you might do is that if the value is less than a certain value, you might subtract the value of that byte plus 10. Going in the other direction, you might do the value plus 14 or minus 17, just add another value in. As long as you then do exactly the same on your decrypt and your encrypt system, then your data is going to be decrypted exactly the same as it started. So adding a couple of other items in here will just make it a little bit more interesting. Now, one thing just to be aware of, don't try and go stupid and add loads of endless values in. Just add or subtract one other value in. The reason for this is that we want to keep this, if you like, encryption as fast as possible. And what we're doing here at the moment is literally going to add only a few nanoseconds to the time that it takes to produce the packet and transmit it. And again, on reception, it's only going to take a few nanoseconds to, if you like, decrypt the entire packet. And as you can see, the data is messed up enough that it would take someone quite a period of time to start to figure out what was going on, especially if instead of using the value that I was using that is incrementing constantly, if we then use something that was a random value that just changed all over the place, that makes it even more complicated. So this is a very basic encryption system, but it will keep your, if you like, your easy hacker out of your data. Now, coming over to Sketch 4, all I'm going to do now is start transmitting the data to the other board. So at that point, I'm going to create my packets of data, and I'm creating my original data here. I'm then encrypting the data, and I'm going to serial print out the encrypted line. I've then commented out all of the decrypt stuff because that bit of code now needs to be added to the board that is receiving it. So this is the broadcast encryption _receive version 4. So when we look at this one, where are we? We have got the information coming into our FIFO buffer. We're storing the data in the FIFO buffer encrypted. Now that's why in the last set of sketches, I didn't do anything to try and decrypt the data in the receive function because I knew the encryption was coming later. So I'm taking the receive data, then I'm going through my decrypt system, and then we serial print out to show that we've decrypted it. Only then do I then go through my code now to check if the system code is correct. Because obviously, if it's encrypted, that system code is going to be wrong. We have to decrypt everything before we can check the system codes are valid. And the rest of it just prints out the data just as I did in the previous sketches. So the two sketches are now running away. Let's just stop them both and just take a look at the data. So we can see we have got 34, 243, 98, 108, which is our system code that then gets encrypted. It'd be nice if we could find that line encrypted. There it is. So this board is now receiving this line of encrypted data. It then decrypts it and we get the values that we sent. Obviously in the resend value I am using the hexadecimal values, but the important thing is I can see that the sending board was number 1, the millis is correct, it's increasing with the correct values, the ASCII character is correct just as before, and my counter is incrementing. So using this, I've just built a very, very simple encryption system that will keep the sort of the lazy hackers out. And I hope that your neighbors aren't the sort of people who'd be wanting to hack encrypted data anyway. But if you just want to keep your data safe with a simple encryption system, this is the sort of way that you can do it. And it's done in a way that processes extremely fast. So for the final sketches, which is broadcast encryption version 5 and the one for the other board receive version 5, the only difference between them is this one's got board address of 1 and it sends once a second, wherever that is, up here somewhere. There we go, board address of 1 and every 1 second. Coming up to the top of the other sketch, it's board 2 and it's sending every 2 seconds. Now I've got it already uploaded, so let's just stop the serial monitors and we can now see that this is receiving the data in the format that I would expect. Number 2 board is sending over to board 1, so we're seeing board number 2 is where this transmission came from. We've got the time incrementing every 2 seconds because this is running every 2 seconds. The ASCII character is increasing, probably not the best part. There we go. U, V, W, X going correctly. And then the counter is incrementing, and the same in the other direction. So as you can see, we've got a very simple encryption system running. Let's just turn that on again. Now, the final test, of course, is to bring back in the wrecker. This is this bit of code in the center that is just sending out random values just to mess the systems up. So as we can see, both of the other boards, let's just move that out the way. Both of the other boards, if I stop the scrolling, are receiving random packets coming through. We can see here that it decrypted as 05191 0323, and we would see that over here on the other board as well. Now, what we need to really be reassured by is, although it decrypted those packets, the only data that it is processing is data that is coming from a correct packet with the board address. So the decryption is done before the check of the, if you like, the address of our circuit, our first 4 bytes that give us that address. And what we can be assured with here is, no matter of the fact that this rubbish is still being broadcast, even with encryption and decryption, that will not have any impact on the data that is coming through. Our data that is being received is purely the data that has our correct header code in it. So everything is working correctly, and I hope that explained a little bit about how to add some basic encryption. Once again, I used the last byte of timer millis for the encryption. If I'd been writing this as a brand new system, I would have probably put a line in here, moved all of these down 1 byte, and added something like, you know, my random value in here, that would have actually, if you like, hidden where the random value was in a slightly better way. But even with what we have here, it's quite enough to keep your sort of casual sniffer out of your system and is going to keep your data safe. The reason we're trying to keep our data safe is not because we're sending official secrets, but it's just we don't want rubbish coming in on our system, and I might not want people to know what I'm sending. So that is the purpose of this encryption. So slightly shorter video today, but I hope that's been useful in a way of showing how to use broadcast mode so that you can now have as many boards talking to each other as you want, way past the 20 limit, and being able to talk to each other in a way that you can still keep your transmissions semi-secure. So, hope that's been useful, and if it is, please click the like and subscribe, and I'll see you in the next video. Bye for now.